The lift mechanism is a building. In a building, this is in a building. In a building, is controlled by 4 doors. We have A, B, C, and D. The lift door is open whenever B and D are in different positions. The lift door is open on condition that A and C are high. Draw a truth table to represent the information. So there are terms that are used in logic gates and Boolean algebra, and these terms are: when you hear of closed, this represents logic 1, and open represents logic 0. When you hear of high, this is 1. When you hear of low, this is 0. Also, a true represents a 1. False represents a 0. So these are these are two state situations whereby we represent them using binary, that is Boolean. So for closed, we term that as 1, open 0, high 1, low 0, true is 1. Another one, it can be on. On is logic 1. Off, it is logic 0. So in some other questions, it may be in terms of switching circuit, whereby you are told these switches will be on in case these are on or off. So off represents 0, on represents 1. So here we have 4 doors, and in case of truth table logic, these now are the same as 4 inputs. These are same as 4 inputs, whereby the output is the open door. The output is the open door because the question is talking of when the lift door is open. That is logic 0. So when drawing truth table, to know the number of rows, you use the formula 2 power n, where n is the number of inputs. So in this case, we are taking 2 power 4, which is 16. So the rows are 16. So we are going to have a truth table of 4 inputs, whereby we are going to have 16 rows. So we are having input A, B, and we have C, and we have D representing the respective doors, and we have the output which represents the open door. So we have that. Let's draw it. So we have that table. So from M, you have to write all possible combinations of these 4. And this is how you do it. So for A, you write 8 zeros: 1, 2, 3, 4, 5, 6, 7, 8, and also another 8 ones: 1, 2, 3, 4, 5, 6, 7, 8. Let me reduce the font for this. We have let me draw again. So we have 0, that is 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Then when you go to B, you alternate 4 zeros, 4 ones, 4 zeros, 4 ones, up to D, reducing the groups by 1. So we have 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. Then for C, here we are not considering any conditions in the question. The truth table for the inputs, that is what we are making. So we go for 2 zeros, 2 ones. 0 0 1 1, 0 0 1 1, 0 0 1 1, 0 0 1 1. Then if we go for 0 1 0 1, like that. So that is how you alternate, even if you have what kind of inputs, be it 5, be it 2, be it 3, depending on the number of rows. So you have 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1. So that is the truth table for the inputs part. So to determine the output, we have to consider what the question says. The question tells us that for the lift door to be open, B and D are in different positions. Different positions means B and that is B and D will not, the lift door is open whenever B and D are in different positions. In different positions. So it means B and D should not have same logic. Should not have same logic in order to have the door open. Meaning, either of them should have a 0 and the other one a 1. When one is at level 0, the other one should be at level 1. And if the other is at level 1, the other one should be at level 0. That is what we mean by different positions. So in this case now, we consider the situations whereby B and D have got no same logic. So we have, for example, in the first one, B and D are in the same level. So that is not the condition that we are looking at. So in the second one, B is 0, D is 1. So the door will be open, which is representing logic 0. Remember, open is 0, is represented by 0. So also when we look at the fourth row, you find that we have the same level. Here we have BD, not same level. We have a 0 here. We have also the next one is also a 0 because B is 1 and D is 0. Then next we have 1 1. So that is not the condition. Then next we have a 1 and a 0, whereby we get a 0 here. So you will check at the positions whereby these two have different logics, and you'll find that the next one will be the next one will be here. The next one will be here. Then we have the next one there, 0. Then we have also, we are looking at where B and D are in different positions. So we have 0, we have 0, we have 0. Then the other position is, let's check whether we have any other where they are in different positions. This is not different position, this is different position. So we have and 0 there. Also we have so we have this and this, yes, 0, 1 and 0. We have also 0. Then we have 1 and 1, not. Then we have BD, 0. Then we have also we have 1 and 1, that is not the same. Then another condition is that the door is also open on condition A and C are high. So it means A and C should have logic 1 in order to have and 0 on the open door. So we consider where A and C have 1. So you'll find that A and C, where they have 1, we have also, you can see if the two conditions are also rhyming with one another, because at this position we have A1 and that is not that one. We have A1 and C1. So here we are having and 0 at this point. Also we consider another point where they have 1. We have A1 C1, we have 1 0. So as at this point you can see that A is 1, C is 1, we have 1 0, and this 0 we wrote it here when we were considering B and D. So the two conditions are also rhyming with one another. So the last one will also be 1 0 because A is 1 and C is 1. So at that point now, after you determine what is being tested, or when the door is open, in all other rows or in all other positions the door will be closed, which is logic 1. So we have a 1, we have a 1 there, then we have a 1, we have a 1 and a 1, we have 4 zeros, then we have 1, and we have 2 zeros. So when you look at the question and this table, you see that it is the truth table is obeying the conditions. If B and D are not the same, then we have a 0. If A and C have a 1 both, then we have a 0. Then all other positions the door will be open, which is logic 1.